In this video, I'm checking out the latest Linksys EA6500 dual band 802.11ac router, as well as the WMC 710 wireless universal media connector. So this is single band on 5 GHz and connects wirelessly to the router and gives you 4 gigabit Ethernet ports to connect your TV, console, or other device. If you want to learn more about 802.11ac, check out some of the links in the description or the YouTube videos. 802.11ac is the newest wireless standard, and this is using the draft standard, but it will be firmware upgradable once that comes out. So out of the box, this router supports up to 1300 megabits per second. So I'll be doing some reviews, copying files as well as streaming, just to see how it holds up. A few of you know that I have a background in IT, and 6 years ago I actually wrote my engineering project. This is the Canadian Iron Ring for engineers on 802.11n and how to deploy wireless networks at Carleton University. So I'm looking forward to putting this set through its paces. Now, just for a quick unboxing, this review kit was sent to me by Linksys Canada, or Cisco, and as you can see, it's still in the shrink wrap. And most routers are pretty standard. I actually have to pull it all off. Inside you've got a very big power brick. So it is 12 volts at 3.5 amps. And then you've got the router itself. A setup CD as well as a Ethernet cable. So the router is what you expect from a router, not much to say. It is both flat mountable as well as wall mountable. And on the back here you've got 4 gigabit Ethernet ports, the WAN port for your modem or cable or DSL, as well as 2 USB ports for printers or file sharing, so a hard drive or a printer, and then just power and reset. On the media connector, we have the setup CD, instruction manual, and the box itself. So again, just WPS or refresh or connect, and on the back are the 4 gigabit Ethernet ports. So again, this is single band 5 GHz 802.11ac and connects to the router. So we give you 1 Ethernet cable in the box and power adapter, and this thing is rated at 12 volts, 1.5 amps, so a little less than the router. I'm going to get everything set up, and then I'm going to walk through some of the tests that I'm going to do with the router and the media connector. Just a quick walkthrough of the dashboard, which can be accessed both locally as well as through their Cloud Connect service, which allows you to access the router anywhere you have internet access. There's also apps for iOS and Android, so anytime you have internet access, you can log in and control your router. This is convenient if you're managing your router wirelessly or remotely, or changing things like parental controls or guest access while you're away from home. So just a quick walkthrough of the dashboard. First up is device list, which is self-explanatory. Next you have guest access, which allows you to create a second wireless network, but block file sharing and access to your main network. Parental controls allows you to block internet access for different times as well as sites. Media prioritization is a quality of service or QoS management, so you can actually choose which devices have high priority. So if you're streaming, you can have high priority on your TV or other devices. As well, you can choose specific applications like Skype or specific games like World of Warcraft, StarCraft, etc. So you can enter in the game and the ports, and anytime those games access the network, they'll have high priority, so less lag and dealing with other issues like that. Next up is the speed test, which is testing your broadband connection. USB storage allows you to set up either a media server as well as an FTP server and access USB sticks and hard drives. As for USB support, this does support NTFS. This is a 64 gig USB 3.0. The router is just 2.0, but it will read NTFS files. So files over 4 gigs. Just gonna set that up. Now in router setup, if you go to USB storage, it'll pull up the USB stick or hard drive. So there's all 64 gigs or 58 gigs on the Sony stick. You can access it directly using the File Explorer, or you can turn on FTP server or DLNA. You can also control who has access to it. So secure or insecure. As well, you can choose which folders have media content, so you can only index certain folders on the USB stick. Connectivity settings. So this is things like firmware updates, which can be automatic. They also update over the air. Time zone, daylight savings, you can turn off the lights. You got your internet settings, cable, DSL, etc. DHCP, routing, and administration. Troubleshooting, MAC address diagnostics and logs, and wireless. Change your wireless settings, 5.0, 2.4, MAC filtering, WPS setup. So there's your PIN. One other thing that I forgot to mention is the router comes with a simple tap card, which is NFC, and you can download an app for your NFC mobile device and then just tap this card to connect it to your Wi-Fi network. So just a convenient, quick way of connecting instead of entering in a password once you download the app. Cancel. And then last is security. So here's router settings, DMZ, firewall, etc. To start off, I'm going to do some Wi-Fi tests on 2.4 and 5.0 while using gigabit Ethernet as the baseline just to test the router's performance and range. Right now I'm in a tiny little basement while my place is under construction. I'm supposed to move in next year, so I'm back at my parents' where I'm going to do the tests on the main floor, in the basement, as well as out in the backyard just to simulate some real-world conditions. This laptop is equipped with the latest Ultimate N6300 Wi-Fi card, which supports the full 450 megabits per second using a 3x3 antenna array. There's only been one laptop that's been announced that has built-in 802.11ac, but it isn't yet available in Canada. And just to show the laptop card itself. So I'm going to copy from another desktop on the network that's also connected using gigabit Ethernet, and copy it over to the computer. I'm just going to pull up a stopwatch. Sorry. As you can see, it's copying at about 55 megs per second. So it took about 25 seconds, and now I'm going to log into the router, and I'm going to do the tests on all three different protocols, so 802.11n, 802.11g, as well as on 5.0, and just to test the speeds. For the second location in this Wi-Fi test, I'm just going to take the laptop downstairs. It's not a far distance, it's only one floor, but as I'll try to show you, there's always been bad Wi-Fi in this house just because it's over 50 years old. And instead of drywall and wood, it's all brick. And this isn't drywall, this is actually plaster and concrete. And it's all steel mesh because it is plaster and concrete. So I'm just going to take it into here, which is the living room where the TV is. And I'm just going to repeat all the same tests over. With that last test complete in the basement, I'm now going to take the laptop outside into the backyard and repeat all the same tests again. So the router is approximately up there, and all the way up to the backyard is about 120 feet, give or take. So I'm literally just going to leave the laptop on the back here and run all these tests again. There's at least one giant thick brick wall and then two interior walls to the router. And I'm just going to repeat all the same tests over again. So unfortunately on 802.11n outside on the 5 gigahertz band, I can't actually get a signal. Oh, I have a signal, but I'm actually not connected, and I can't actually access the router. So I'm going to walk back inside and switch it back to 2.4 and repeat the tests. So I've switched it back to 2.4. So 802.11g, and I'm just going to run the tests again. So if I walk back up the driveway, look up here, the router is approximately right here and straight in. So we're about 50 feet closer, and I'm gonna see if I can connect and run these tests again. But unfortunately, if you can see right there, it just started raining outside. So I'm gonna have to redo these tests when it is not raining. So those are the end of the tests, and whether you jumped here directly or actually watched all those boring tests, I'm just going to summarize some of the numbers and the results. So first off, there's the 4 different Wi-Fi protocols: 802.11g on 2.4, 802.11n on 2.4, and then 802.11n on 5.0 with different channel widths. So obviously the wider the channel, the bigger the bandwidth and the more data. So first off, this is the main floor, and as you can expect, when you're on the same floor with minimal interference, just drywall, you'll get pretty decent speeds and very fast transfers. Moving down to the basement, you'll see this big jump. That's because 802.11n is a more complex protocol, and if you have a weaker signal, it's actually worse than 802.11g. Moving on to the backyard, I can get a signal on 2.4, but not on 5.0 because the higher the frequency, the shorter the range, and the worse it penetrates through different materials. Lastly, we're just out in the driveway. You'll see this here. Even though these two are both 802.11n, you have a weaker signal on 5.0 than on 2.4. And that's made up for when you switch over to a higher band, a wider channel. Next up, we have the transfer speeds. This is in megabytes per second, not bits, so not the number you see advertised on the box or with your cable internet connection. This is the number you'll see on, Windows File Explorer transfers or other applications. 2.8, 4.5, and then when you switch over to 5.0, you'll get that big boost. Again, the big boost when you switch over to 5.0, especially with the wider channel. No connection, and out in the driveway. This is the same chart, but in megabits per second, so these are the numbers you'll see advertised on the box. So when the router advertises 54 megabits per second, and again, there's 8 bits in 1 byte, so to get this, you just multiply by 8 from the previous slide. So just all the same stuff. Just some factors that affect Wi-Fi performance. Obviously, building materials. If you're behind brick walls, it's going to block the signal. Very dense things, concrete, steel, etc. Next up, water. Anything that holds a lot of water, aquariums, water heaters, this water wall for instance, that's organic and dense will block a Wi-Fi signal. And then obviously interference. If there's lots and lots of other Wi-Fi networks, there's only so many channels to go around, and thankfully most Wi-Fi routers will automatically find the strongest channel and set up there. But you can also get interference from things like cordless phones, Bluetooth mice and keyboards like my Logitech MX5500, and especially Bluetooth. Bluetooth is a very, very noisy and unorganized protocol. And last but not least, microwave ovens. They also produce a lot of 2.4 gigahertz interference. And of course, distance. The farther away you are, the weaker the signal, and you can't beat physics. Software factors affecting Wi-Fi performance. First up, encryption. Obviously it introduces overhead with having to encrypt and decrypt the packets, but anything's better than using an insecure network, and WEP also really sucks. Don't use it. Next up, software protocols. These things obviously add overhead, so TCP/IP has send and acknowledge, and then has error correction and transmission control, and all these things add overhead. Next up is Wi-Fi itself. So obviously the frames have to have their own control bits and signals and cyclic redundancy checks and everything in there. So these things also add overhead. There's also spacing between when it can send packets as well as its own acknowledgements, retransmission, and interference. So if you're wondering how fast you need your Wi-Fi network to be to do certain things, these are just a few samples. So if you're streaming 1080p files, so MKVs, you're going to need 15 to 25 megabits per second. This is megabits again. Depending on how dense the file is, what type of audio, what type of compression, etc. Netflix and Hulu, only 5 to 10. Skype, audio is only 100 kilobits, but if you add in HD video, it's another 1.4 megabits on top of that. And Intel wireless display, again, another 5 to 10. Touching on Cisco Cloud Connect and Linksys Smart Wi-Fi, if you do a search on Google, you'll get a ton of results. This is because back in June, Cisco updated their Wi-Fi firmware to only allow you to access the router through the cloud. So you had to sign up for a cloud account and you couldn't manage the router locally. Fortunately, since then, because of all the user protests, they've switched it back, and now you can manage it both through the cloud as well as just locally. And Cisco Cloud Connect or Linksys Smart Wi-Fi is totally optional. You don't have to install it or register for an account if you don't want to. For those that are curious, this is the setup at my parents'. First off, I've got the D-Link EA6500 Extreme. It's a 2.4 GHz single band, 300 megabits per second N router, and plugged into it is a cable modem and then another switch for another 8 ports. This is the PC I was copying everything from, as well as a bunch of other devices. This is my desktop here. In the basement is another access point with dual band, and I'm running it on 5.5 gigahertz, as well as another switch for the various devices, the TV, the PlayStation, and then the server and everything else. So in conclusion, it's got excellent range. I didn't need that second access point, and it's got good performance. I really like the management dashboard. It's very neat and organized, and you can manage it either locally or through the cloud, which is convenient, since if my parents need anything changed, I can log in from wherever I am. And there's also specialized apps that I didn't touch on that allow you to do things like parental controls and filtering. The 2 USB ports are also useful if you want to share peripherals or hard drives or USB sticks. So now onto the cons. Obviously price, because it is the newest Wi-Fi protocol and one of the first 802.11ac devices, it's going to be more expensive than your typical router. There's a lack of AC hardware except for the wireless media bridge, but you'll see more devices come out in 2013. And lastly, I prefer to have external antenna connections just because I have a bunch of antennas that I can connect, but this does have a 3D antenna array with multiple antennas inside for MIMO, so multiple in, multiple out. And that concludes part 1. In part 2, I'll be looking at 802.11ac using the wireless media bridge and performing many of the same tests. As always, if you have any questions, leave a comment, and everything is in the description, the charts as well as other relevant links. Once again, thanks for watching.